Okay guys, well, a while ago I made a video on how this thing works, and when I did, I skipped the pressure relief valve and all the details about it. I skipped over it pretty much completely, if I remember correctly. Anyway, here it is. This all goes in that little hole there. When it's in the truck and it's not taken apart, this plug does not have that hole right there. It's just a normal plug, and it's flush with the housing. The pressure relief valve function is really easy. You just got the ball, spring, and the plug. I mean, it all goes in there, and it works as a pressure relief valve. This side of the ball here gets connected to the high pressure side of the piston, and through this little hole there. Can you see it? Yeah, I think we got a shot there. That connects down here through to the other side of the ball. So when the pressure relief valve is open, fuel can go through from the high pressure side to the low pressure side and not go through your injector pump. So any fuel that goes through here is not going through your injector pump back into your return line, is low fuel flow. So anything going through here will decrease the amount that's going through your injector pump. Really simple stuff. Anyway, obviously it's a good idea to have that on the lift pump for safety reasons. I mean, if somebody kinks the return line accidentally or something happens like that, you don't want the amount of pressure this thing can probably put out to go through your injector pump. That probably wouldn't be very good. Now, the thing that makes this important is that this pressure relief valve is actually open a lot of the time. I don't know how often, but I'll tell you this little story from my personal experience. A while ago, on my modified pump that's in the truck, I had an issue. When I had great fuel pressure and great fuel flow at idle, but then once I took it up to about 1500 RPM, truck ran like crap, and fuel flow and fuel pressure was zero. I mean, it was just like a switch. It'd go from great to horrible, just like that. Then it would continue to be just like crap until you took it about to 1000 RPM, and then it would, just like a switch again, it would fix itself and great flow, great pressure again. And after a little bit of diagnosing, I found out that my pusher pump that had died shortly before sent metal shavings into this little port here, this little, hole, and the spring was binding. So at 1500 RPM, it would start to open, and it would stay open, and because the spring was binding, and let fuel just go through without having to overcome the pressure first. That was at 1500 RPM. Now, on that modified pump, one of the things I did when I modified it was I shimmed the spring. I made it so that it took 126 psi to open it. Open this little pressure relief valve. That's 126. Now, that is a lot, and, well, I mean, it is a lot, but this guy's stock takes 86 psi to open, and the previous pump, before I modified it, was like 74 psi to open, and so, I mean, that's quite a bit, seeing as that port is directly connected to the injector pump outlet. I thought that was quite interesting. So, if my 126 psi pressure relief valve starts to open at 1500 RPM, then when does this guy start to open? I mean, to me that makes a lot of sense that this is where a lot of the fuel is going. When people talk about crappy fuel pump numbers, or how inefficient this lift pump is, that's a place where a lot of fuel is going. I don't remember the numbers now, but I got some numbers for it before and after I shimmed this little pressure relief valve, and it did make a very noticeable difference. I can't remember for sure, but it was very much worth it. If you do not have enough fuel pressure or enough fuel flow, you can try shimming that. In order to get the plug out, you just drill it, use an extractor bit. With this one, since it has an O-ring, you might be able to get away with just beating it in a little further. You don't want to beat it in more than 0.2 inches, because that's when at 0.2 inches this rod here hits that ball, and the pressure relief valve will never open. So what you want to make sure to do is maybe 0.15 inches max, and then as far as how you get the plug to stay further in, it might stay on its own. You might have to do something, I don't know. With my other one, what I did was I threaded that to a 7/16 inch bolt thread, and then I put my own bolt thread in there, gasket maker, and it doesn't leak or anything like that. And then I just made a shim to go on there to compress the spring more. And then I also used a 1/4 inch bolt, and that's my shim was the 1/4 inch bolt head, so it pretty much looked like that. The head was the shim, and then the rest of the bolt was the this little part here, and that keeps the ball from opening too much. I think right now I have it set up to so the ball can only open 0.05 inches, which that way, if it only opens that little bit, then it can close faster, and hopefully at higher RPMs that makes a difference. That was the idea behind it anyway. That's that. I think that pretty much covers that. And then I was going to mention one more thing. Actually, two more things, but one of those things is, as far as lift pump springs. This spring here is the one that comes in the stock original lift pump, the one that goes on the plunger, like that. This one is you'll hear of Carter started using a new improved spring. Well, this is it here. That's the one that came in this one here. And you can see it's longer, so it provides a little bit more pressure, especially at the, at the not fully compressed but fully uncompressed state of the plunger, what do you call it? And then this is the one I put in. It's about the same length, it's just a little bit longer than this guy, but it's a bit stouter, and I noticed better fuel pressure up in the higher RPMs, above 2200 RPM. Instead of the fuel pressure starting to go down again, it kept going up, which I thought was pretty nice to have, because normally it goes down, and that's where you need it, right above 2500 RPM. Well, this one just kept on keeping the fuel pressure going up. Okay, then one last thing. If you're reading this video, if you're watching this video, then you're looking into how it works, and you're interested in how it works. There's a TorqueTech article, and I'll put it in the description below. It's really a good article, but there's a few places I don't quite agree with him with, and one of those places is how he measures the displacement. He says the stock displacement of this pump is 0.73 cubic inches. Now, that is correct to a point. The travel is a 1/4 inch. This piston is 1.18 inches in diameter. You do the math there, that's 0.273. However, what he's forgetting to take into account, in my opinion, is the rod. If you've watched this, hopefully you've watched the previous video, you know how it works. It goes over here, the piston's over here, and then it lets it out, and then goes in, and fuel gets pushed out, new fuel gets pushed in, and then it comes back, and because of the vacuum here, fuel gets transferred to this side of the piston. Piston. Anyway, well, this whole thing comes back, this rod is also going back, so this rod is taking up some of the areas that the fuel would be in. It's just like a hydraulic cylinder. If you're measuring the displacement of a hydraulic cylinder, if you're measuring how much displacement is on when it goes out, then you just measure the diameter and the travel. But if you're measuring how much when it comes in, you have to take the shaft into account. It's how it works. This is the same thing. And because of that, I believe the displacement of the stock lift pump is 0.254 cubic inches. Not a big difference, but it kind of makes the numbers look a little better when it comes to how efficient it is. And so that's all I have for this video. If you got a question, ask it. Comments, whatever. I'm not by any means a lift pump expert, but I might be able to help you a little bit.